Hello and welcome to the controller word application video for Team 6165 MSET Cuttlefish. At the start of Autonomous, the robot uses a Logitech webcam to scan the 3 tape markers using a custom OpenCV vision pipeline to determine where the team shipping element is based on which bounding box has the lowest amount of red or blue pixels, indicating the team shipping element is covering it. Afterwards, we use the Roadrunner trajectory generation library in combination with a path follower called Ramseat to navigate the robot to the Alliance Hub. Ramseat is an FRC level algorithm that we adapted for use in FTC that allows six-wheel drives such as ours to accurately follow complex trajectories while also managing horizontal error. After depositing, the robot then begins to cycle the warehouse, but because we have a wide 6-motor drivetrain, we found that crossing the barrier poles would actually stall the motors and spike the current to a dangerous level. To prevent the battery's fuse from being blown, we integrate the total current draw of the system over time. After it has exceeded the battery's fuse rating, we proportionally lower the power delivered to the drivetrain motors. This allows for both fast and safe driving. Our robot localizes its position using a combination of drive encoders and the RevHub's internal gyro. However, the encoders tend to slip over time, especially when going over the poles. To account for this, we relocalize our position upon entering the warehouse using 4 distance sensors mounted on the sides of the robot. The distances from the walls, in combination with the sensor offsets and the robot's pitch, tilt, and heading, allow us to perfectly relocalize the robot.
An issue we noticed while testing is that our intake's extension moves faster than the dropdown, causing the intake to sometimes fall directly on top of freight. To solve this, we implemented a feature called Servo position estimation, which allows the intake to drop down before fully extending, but also allows the driver to cancel and resume the action with optimized timings.
Once in the warehouse, we use a color distance sensor to automatically retract the intake upon freight collection. In teleop, the sensor is also used to classify the freight and dynamically adjust the level to which we deposit, in favor of maximizing the holding capacity of the hub. We notice that the readings from the color distance sensor are quite noisy, which causes some false positives. So to mitigate this, we use a low-pass filter to ignore any erratic values.
The height of the lift is controlled by a simple PID F loop shown on screen. Thank you for watching.